Hey everyone, today we are looking at measuring angles in radians. So the first thing that I want to kind of explain to you guys is when we're looking at length, say I wanted to measure the distance between 2 points. I can do that in inches or centimeters or miles or meters or whatever we want, whatever unit of measure we would like to do. Okay. The same thing is true for angle measures. Okay. Our typical unit that we've used all year has been degrees. But beyond that, there is another unit of measure. It's called radians. Okay. A radian is the ratio, okay, of the length of the arc and the length of the radius. Okay, so when we're looking for the radian measure, we can divide the length of the arc by the radius. Okay, so when we look right here, this is our formula for finding the length of the arc. All right, so it's that degree of the arc over 360 times 2 pi r, where 2 pi r is the circumference. Okay, and the degree over the arc tells you how much of the circumference we want. This is the portion of the circle that we have. So if I take the arc length formula and I divide it by the radius, okay, we divide it by r, then these r's are going to reduce to 1. So then I'm going to get this formula over here, the degree of the arc over 360 times 2 pi. Remember that this is 2 pi over 1, and these are being multiplied together. So I can put them in any order I want. So all I'm going to do is switch these two. Again, I can do that because they're being multiplied to get here. So it's going to be 2 pi over 360 is the measure of the arc. Okay, and if I reduce this 2 over 360, I'm going to get pi over 180. All right, so this right here is what is important. All right, that our radian measure is going to be equal to pi over 180 times the degree of the arc. All right, so if I think about this in terms of, like, let's say a line, we could say that this is y equals pi over 180x. Okay, if we call these our y and our x. This here, if I were to graph this, that pi over 180 is your slope. Okay, remember the slope of your line is also called the constant of proportionality. All right, so the constant of proportionality between the relationship between a radian and degree is pi over 180. So like if I look at this and I plug in 1 degree, okay, plug in 1 degree right here. 1 degree is going to be equal to pi over 180 radians. All right, if I plug in 1 here for 1 radian, I'm going to equal pi over 180 times, I'm just going to write DEG for my degree. Okay, so in order to solve for my degree, I would multiply both sides by the reciprocal. So I'm going to get 180 over pi is equal to my degree. Okay, so 1 radian is 180 over pi degrees. If I were to plug in 360 degrees here, okay, I would get 360 times pi over 180. That's going to reduce to 2 pi. So a full circle is 2 pi radians. All right? So the big thing that you need to get out of that is if I am trying to convert angle measures from degrees to radians, I'm going to multiply the number of degrees by pi over 180. Okay, if I'm converting from radians to degrees, I'm going to multiply the radians by 180 over pi. So let's take a look at some examples of doing exactly that. So I want to convert 30 degrees to radians. So I'm going to multiply 30 times pi over 180. And this is going to give me 30 pi over 180. Okay, and then all I want to do is reduce this fraction. Okay, if we start with the easy reduction and divide both of them by 10, okay, I'm going to get 3 pi over 18. Well, 3 over 18 is going to reduce to 1/6. So I'm going to have 1 pi over 6, and that is our radians. Okay, we're going to do the same thing over here with our 75 degrees. Okay, so I'm going to multiply 75 times pi over 180. This is going to give me 75 pi over 180 degrees. Now, especially if a problem like this is on maybe your non-calculator day, maybe it's not so easy to figure out what the greatest common factor is between these two. Okay, so what I want to look at is start with the easy one. I know they're both divisible by 5. So if I take 75 and divide it by 5, I'm going to get 15 pi. Okay, if I divide 180 by 5, I'm going to get 36. So then I can see that both of these are still divisible by 3. So 15 divided by 3 is 5, so my numerator is going to be 5 pi. 36 divided by 3 is 12. So we're going to get 5 pi over 12 radians. And again, if you notice that this was immediately, oh, I can divide both of those by 15, you can obviously skip this step and go straight from here to here. And that's more than fine. And you can do that on a calculator day. But sometimes it's easier on a non-calculator day to maybe take the middle step. All right, let's take a look at another example. Now I want to go the other way. I want to convert radians to degrees. So I'm going to take pi over 4, and I'm going to multiply by 180 over pi. So what I'm going to get here when I multiply across the top is 180 over pi. Multiply across the bottom, I'm going to get 4 pi. Our pi's are going to reduce to 1. So then I can take 180 divided by 4 and get 45 degrees. All right. One way to help you remember whether you're multiplying by 180 over pi or pi over 180 is to look and see. Radians is going to mostly have a pi in it. You want to cancel that out. All right. So that's why we're going to divide by pi. Degrees, you want to put in a pi to make it go to radians. So you want to put the pi in the numerator. All right. Now, one thing that you should notice here about part B is that this is negative, which is not something that we've normally dealt with. So what we're going to do is we're going to go ahead and convert this for a second, and then I'm going to talk you through something really briefly about why we can have the negative. All right. So I'm going to start by multiplying negative 5 pi over 9 times 180 over pi. All right, again, my pi's are going to reduce to 1. So I'm going to do 5 times 180 is going to be 900. And then 9 times 1 is 9. And again, we want to keep this negative in the front. So this is going to be negative 100 degrees. All right, so let's take a look at something for a second. When we're talking about radians, one of the things that we're going to look at is what is called the unit circle. All right, and just for a quick second, so remember pi over 4 was 45 radians, or 45 degrees, excuse me, and negative 5 pi over 9 radians is negative 100 degrees. So we're going to kind of make a little note of that. So it was pi over 4 was 45 degrees, and negative 5 pi over 9 was negative 100 degrees. Okay, I'm just going to block this off for in a minute. Okay, so we're going to take a look at this circle. In your unit circle, your radius is always 1. All right, so let's think about this. Remember that I'm going to take my degree and I'm going to multiply it by pi over 180. Okay, so when I'm converting to radians, this is where it goes. So if I have 0 degrees, okay, I'm going to also have 0 radians. The important thing to know here is that everything that we do is going to come from this side. All right. So when I'm looking at this, I'm going to start from this side and go up 0 degrees. So this is my 0. Well, we said that pi over 4 was 45 degrees. So from this line, if I come up about 45 degrees, this is going to be pi over 4, or 45 degrees. Okay? If I look at 90 degrees, 90 over 180, so if I do 90 pi over 180, this is going to equal pi over 2. So right here is going to be pi over 2. Okay, if I keep going and I do 180 degrees, it'd be 180 pi over 180. So this is pi. Okay, if I go and I continue, this is going to be 270 degrees. This is going to be 3 pi over 2. And the full 360 degrees was 2 pi. So now, when I'm looking at these, notice these are my quadrants, right? Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We always start here between 1 and 4 and go around our circle counterclockwise, okay? Just like the quadrants are named, okay, or are numbered. If I wanted to go negative 100 degrees, okay, that means that all I would be doing is going this way. I'd be going clockwise now. So if this is 90, this is not, well, we'll just ish. Okay, we're being very general right now. Okay, so let's pretend that that's negative 100 degrees. So that would be negative 5 pi over 9. So all I would do is start from here and go backwards so that if I were to draw this angle, close enough, that this would be 100 degrees. It's just 100 degrees going clockwise. Okay, so kind of like when we were talking about rotations. Rotations are always counterclockwise unless you're told specifically to go clockwise. The same thing happens with radians. Okay, you're always going clockwise or counterclockwise unless the negative tells you to go the other way. We can also see measures that are greater than 360 degrees. All that means is that we start here and we go around the circle more than one time. All right, so if you have any questions about that, know that you're going to see the unit circle used a whole lot more. You're going to see it in pre-calculus. You're going to see it in Algebra 2 next year. Okay, so know that I'm just giving you a very, very brief overview of it right now, but you will see it more and explained more in depth over the next 2 years. All right, so the next thing that we're going to look at is finding arc length. All right, so when I'm looking at arc length, a common variable for arc length is S. All right, and remember at the very first slide, I said that the radian angle measure, that didn't go, that looks weird, okay, was equal to the arc length divided by the radius. All right, so we're going to take this formula and put it in terms of, symbols, okay? So first things first, we know that the radius is r and the arc length is going to be s. Okay, so our arc length is s, radius is r. This right here is the Greek letter theta. So that is theta, T-H-E. God, my thing is jumping. Sorry, guys. T-H-E-T-A. Okay, so that is theta. All right. All theta is, it is a variable. It is no different than if I put an x right here. Okay, it is just a variable. That is all that it is. Okay, do not let the fact that it's a Greek letter mess you up. Okay, be very careful, those of you that use zeros and you slash your zeros. Okay, if you slash your zeros, it goes this way. Theta goes across the center. All right, so all I'm going to do is use theta as a variable. Okay, when you get, again, in your next math courses, as you move forward into pre-calc and algebra 2 and calculus honors or AP calc or wherever you get to, you're going to start seeing theta used frequently as the variable for an angle measure. Okay, so when we're looking in radians, okay, my radian angle measure, we're going to use the variable theta. So if I multiply both sides by r, I get that my arc length is my radius times the degree or times the angle measure in radians in this case. Remember that if you are given the angle measure in degree, you're using the measure of the arc over 360 times 2 pi r. Okay, this is your arc length for degrees. This is going to be your arc length formula for radians. All right, so let's take a look. I want to find the length of arc AB. We're going to go ahead and just call it S to make life easier. All right, when the measure of my angle, theta, is 3 pi over 4, when you see your angle looking like this, that is in radians. Okay, they may not always say radians, but it's radians. Okay, and my radius is 6 feet. So what I want to look at, my formula, is that my arc length is my radius times my angle measure in radians. So my arc length is S, my radius is 6 feet, and my theta is 3 pi over 4. Again, remember this is like saying 6 over 1. So when I multiply across the top, I'm going to get 18 pi. Multiply across the bottom, I'm going to get 4. I'm going to reduce this to 9 pi over 2. Now, here's the question of the day. If I'm measuring the length of this arc, okay, what unit of measure should I be using? All right, this is a distance, not an angle. So I want to use feet. So this is 9 pi over 2 feet. All right. On the back of your notes, you will find several practice problems. Each section corresponds with an example. So that is something that you guys need to get done. And then as always, if you have any questions, just let me know. Have a wonderful day.